In this work, we propose the unsupervised cross-modal homography estimation framework via intermodal self-supervised learning, namely SCPNet. Homography estimation aims to compute the global perspective transform among images. Present supervised homography estimation approaches can usually handle the homography estimation task under large offsets and modality gaps. However, in real applications, the homography deformation between images is usually unknown. Therefore, unsupervised cross-modal homography estimation is vital for real-world tasks. To cope with this difficulty, unsupervised homography estimation is then investigated. These approaches mainly use intensity-based loss as training objective, which monitoring the content similarity of the warped IB and IA. Nevertheless, as the cross-modal image intensity similarity is generally highly non-convex, the training process is prone to fall into non-convergent. Inspired by multitask learning, we propose intermodal self-supervised learning to achieve better supervision. The motivation of our intermodal self-supervised learning is to enhance the unsupervised learning process by introducing highly related extra tasks that provide direct supervision. While obtaining cross-modal ground truth homography is challenging, intermodal ground truth homography can be easily generated by directly applying simulated deformations. This allows the knowledge of homography transformation to be directly learned, rather than indirectly as in common cross-modal intensity-based learning. To validate the aforementioned statement, we train a weight-shared network to separately predict the homography within the two modalities under direct supervision from simulation, and compare it with the cross-modal intensity-based learning. Interestingly, we find that the network trained by intermodal self-supervised learning has an evidently better cross-modal performance than the common cross-modal intensity-based learning trained one. Therefore, we can obtain the finding: the cross-modal homography estimation can be indirectly facilitated by training the weight-shared network using the simulated transform within the two modalities. Based on the above finding, we propose the unsupervised cross-modal homography estimation framework that adopts intermodal self-supervised learning, correlation, and consistent feature map projection, namely SCPNet. In homography estimation network, the correlation constrains the network to learn a clearer knowledge that can be generalized from intermodal to cross-modal. Moreover, we use the consistent feature map projector to provide consistent feature maps for both homography estimation and cross-modal intensity-based loss. The complete framework of SCPNet can be determined by combining the above learning strategies and modules. The training framework of SCPNet contains 2 self-supervised learning branches and 1 cross-modal learning branch. 2 self-supervised learning branches are supervised by the ground truth homography, and the cross-modal learning branch is supervised by the content similarity of consistent feature maps. As for the inference phase, only the cross-modal prediction branch of SCPNet functions. Here, we show ablation on the architecture and supervision of our SCPNet. The intermodal self-supervised learning is the key for network convergence. Moreover, the results show gradual improvement as additional ablation components are incorporated. We further show the consistent feature maps produced by concatenation and correlation architecture. The correlation visibly facilitates the consistent feature map by the direct constraint of inner product. Here, we show the performance comparison on cross-modal datasets. It can be observed that our SCPNet outperforms other unsupervised approaches. Here, we show the performance comparison on cross-spectral datasets. Our SCPNet consistently surpasses other handcrafted and unsupervised approaches on Harvard and RGB/NIR datasets. Here, we visualize the homography estimation results of SCPNet and other comparison approaches. In a word, in this work, we have proposed a novel unsupervised cross-modal homography estimation framework, named SCPNet, which consists of intermodal self-supervised learning, correlation, and consistent feature map projection. Extensive experiments demonstrate the effectiveness of SCPNet in handling large offsets and modality gaps. Thanks for watching.